Hello. The purpose of today's discussion is to give you a little bit of material or information to be able to successfully complete exam one for EET 423. It is a take-home exam, and you are permitted to have the time that you need, hopefully the time that you need to go ahead and get the information and be able to submit a quality result. What my expectations are is that this is a take-home exam, and so you should be able to um, get all the information you need and provide a very quality, professional-looking document. This is something that we're working with industry folks who are I can't talk, presenting the material. So we need to be able to show something that looks at the same level of quality. So that's why these 6 bullets are really important. I want to see clear information, so you should type your responses, make it very clear. So my suggestion is perhaps to, if you want to include the discussion of the problem for problem number 1, and any assumptions you made, they should be typed out and that type of detail. Also, logic diagrams. There are lots of software applications that you can do logic diagrams. What I mean by that is AND gates, OR gates, NOTs, flip-flops, generic blocks. You should be able to find applications that you can do that really easily. And those are some free applications that you can do that. You can also use AutoCAD, which is if you're a University of Maine student, you're welcome to use AutoCAD. Visio is a program that you have to purchase, but that has worked really well to do some of the logic diagram features. And there are some built-in logic diagram features in the Microsoft suite of products. So any figures, so if you're using references, you need to include anything with figures to help convey the material, the information you are trying to do. So when you're laying these documents out, my suggestion is it's almost like you're explaining it to yourself. Where did you get this information? Where did you pull this data from or this information from? And by doing that, what you'll find is that it's going to be very easy to follow your work, and you'll actually be able to explain it to me because I have a good understanding of this material. So the expectation would be that you would, if you can explain it to yourself, you can do it as well. Any references you needed, make sure you cite them. Quick set files or instruction manuals, et cetera, et cetera, et cetera. Any electronic files, so if you have to do some calculations, in Excel, for example, you may want to include those here. Quickset is also really important if you're going to do an RDB file to make sure that it works properly. Make sure you include the RDB file. And then finally, anything that if you're using the front push buttons or the LEDs on the relays, you should include a layout and then indicating what those buttons are. If you go to the Schweitzer website, they have Word files that you can download, template files that actually will provide you the information of what looks where, and then you can just append to that. So again, it's expected that you're going to be working independently on this. You're not going to be working with anybody else. So keep that in mind, that you need to have your own work. So the first problem is counts for a lot, but this is one of the nicest things about microprocessor-based relays and protection is the fact that you can do a lot of internal logic within the relay. And so what we're trying to do is see if we can actually get some control and capability of our machines using the built-in features of the relay. So we're going to be using the front panel extensively for this assignment to go ahead and have some control, but also to display some information. So when I say PB1, PB5, those are indicative of the actual front panel push buttons. Same thing with PB2, but just be careful. You'll notice that there are different LEDs that move things around. So push button 1 is going to be local control. You want to enable local control, which doesn't actually mean that you're doing control. That would be a separate indication. But the PB1 control is now I'm ready to place it into local control where the operator sitting in front of the relay can actually control it. That should be indicated with the LED being turned on. So you can specify PB2 LED to indicate that. Don't worry that it's PB2. We're just trying to see if you can use the LEDs properly. Then you have PB5, which is tagged enable, which is do not reclose. So this is a case where you would do a lockout tagout procedure. And some of the manufacturers or some of the companies are implementing tagging on the front of the relay. So they hang a tag on the front of the relay, but they have this push button. So the only way that they can lock out the local control is that they have this tagged feature. Notice that your tagged can only cannot be enabled if you are in local control. It's got to be enabled only when you are in local control mode. You have an input that indicates the status of the breaker, which makes sense. So a 52A contact indicates that the breaker is in fact closed. So that has to come in from an input. Now, the other thing too is this is where you have to do some research. So one of the things that companies do is if they have a transmission line that they've done some work on, they sometimes will ground each end of the line to make sure that if some odd circumstance where something closes in, then the staff that are working on the line are protected because they can see that the line is grounded. So the voltage won't go unexpectedly high. It'll actually be detected from a trip, detected by a relay and actually cause a trip. So it provides a level of protection where you would hang these ground wires. And then the other thing too is that the relay needs to be able to detect if the grounds have been left. And if you think about the sequence there, hopefully you'll understand what happens when you first close that line and you have that issue. And it only happens when you first close the line. It doesn't happen for longer periods of time because once the line has been energized for a while, you should have sufficient voltage and current so that the system can detect if there's a fault. This is only if the system has been sitting there for a while with no voltage, and then you expect it to operate properly just after the switch has been closed in, and the relay detects that there's a fault, but it can't detect necessarily what's happening because the voltage is really poor. So that's why I said here, it only needs to be monitored for 10 cycles in this particular case. This shows you a generic configuration, a single line representation of how a 421 relay would be perhaps connected. It has some additional PT inputs if you want to go ahead and do some sync checking. But the reality of it is like that this is just a very basic setup. That's problem number one. Problem number two is zones of protection. And so why are zones of protection so important? If you remember Adam and Jack, when they spoke about sort of the P&C, the protection and control aspects of things, it was a really important feature to make sure you have zones of protection and you can define those. And then that helps you ascertain whether you have sufficient protection of your system. So make sure that you describe what that means. An FT test switch. And so this is the part where I believe Adam spoke about FT test switches, which are the ways that we can isolate a relay from a current transformer. And we use a test switch. And we use a test switch because it provides a safety capability, but it also provides a really convenient testing location for injecting and determining if the relay is operating as intended. So you need to specify the type of test switch that actually will work really well to meet the criteria. So you have an FT test switch that shorts out 3 phases of neutral, and then it includes 2 standard open switches. And so you'll see that there are up to 10 switches on a typical CT test switch. So just go ahead and specify the part number for that, and make sure you include any information you get from a website, configuration, etc. The next one is, here is a very simple portion of a DC circuit, and I'm talking about fusing, and you should be able to look at this and tell me some information about the fusing and why it is enabled as shown. And the last question is about DNP. So this is Mr. Perkins' information. And so how do you map points using a DNP map? How do you configure that correctly so you get proper operation? So that's it for a brief discussion. Feel free to reach out to me if you have specific questions. And if they're consistent questions amongst the group, I will post things to Brightspace and provide answers. With that, good luck on this exam. I hope you do really well. And thank you very much for your time and have a wonderful day.